Okay, let's dive into this. Welcome to this explainer, where we take some pretty complex architectural concepts and, well, make them perfectly clear. Today, we're unpacking a crucial blueprint for modern software design, architecting message flows with Azure Service Bus. If you've ever found yourself wondering exactly how massive, global applications manage millions of requests without dropping a single piece of data, you're definitely in the right place. We're going to look really closely at the architectural diagrams and those step-by-step message flows that make true enterprise-grade reliability possible. Let's get started.
Here's our roadmap for the explainer today. We'll start with number 1, the microservice problem. Then move into number 2, enter Azure Service Bus. Number 3 covers queues versus topics, followed by number 4, the step-by-step flow. Finally, number 5, when to actually use it. We're essentially moving from a totally tangled communication mess to a crisp, clear, scalable architecture. All right, kicking things off with section 1, the microservice problem, tightly coupled chaos. Picture a really busy restaurant kitchen. Now imagine if every single chef had to directly hand off their ingredients to every other chef, all at the exact same time while shouting instructions at each other. It would be a total disaster, right? Well, in software, when every application talks directly to every other application, which we call synchronous point-to-point communication, your system becomes incredibly fragile. It's just a tangled web of tight coupling. Think about it. If your billing service has a synchronous dependency on your inventory service, and that inventory service drops offline for just a few seconds, what happens? The connection drops, the data's lost, and the billing service literally crashes just because it's waiting for a response that's never going to come. At scale, this tightly coupled chaos makes systems practically impossible to maintain, troubleshoot, or safely upgrade. Which brings us to section 2. Enter Azure Service Bus, the digital post office. So the crucial point is this concept of an enterprise message broker. You can think of Azure Service Bus as a highly secure, incredibly reliable digital post office. It fundamentally shifts your entire architecture by decoupling your applications. So instead of app A calling app B directly and just sitting there waiting synchronously for a response, app A simply writes a message, like a letter, and drops it into the post office. App A doesn't actually need to know if app B is awake, online, or busy. It just hands the data over to the service bus and gets right back to its own work. The service bus then safely manages the delivery of that message, persisting it securely in the cloud. It basically acts as an asynchronous shock absorber for your architecture. If you get a massive spike in traffic, the broker just absorbs that load, queuing up the messages so your backend systems can process them at their own pace without getting completely overwhelmed. This decoupling, it's the absolute secret to building resilient systems that never lose data, even during severe outages. Moving right along to section 3, queues versus topics, architecting the flow. And this brilliantly illustrates the core architectural decision you're going to make when setting up your message flows. Now, looking at queues on the left, you have a point-to-point one-to-one delivery mechanism. It is exactly like a personal PO box. The sender drops a message in and a single receiver pulls it out. It's strictly organized, usually operating on a first-in, first-out basis. This ensures that every single message is processed exactly once by one consumer. Topics on the right, well, they introduce the publish-subscribe model, or pub/sub. This is a one-to-many delivery system, kind of like an email newsletter. A publisher sends a single message to a topic, and then multiple different subscribers can receive their own unique copy of that exact same message simultaneously. It's an incredibly powerful broadcasting architecture. It literally allows you to plug in entirely new backend services later on without ever having to touch the original publisher code. All right, section 4, step-by-step flow, the journey of a message. Let's move to and see how this builds a completely fail-safe system. Step 1. The sender generates the message. Let's say a customer just clicked Buy Now on your website. Step 2 is the critical handoff. Azure Service Bus accepts the message and securely stores it. And once it's stored here, it is safe. Even if your entire backend database temporarily crashes, the Service Bus holds on to that purchase request. Step 3, the receiver. Maybe your order fulfillment service pulls the Service Bus, essentially asking, hey, is there any pending work for me? It pulls the message down and begins processing. This is where concepts like idempotency come into play, making sure that even if a network blip causes a retry, the end result stays perfectly consistent. Finally, step 4. Only after the receiver has successfully processed the order does it send a signal back to complete and remove the message from the bus. This exact step-by-step flowchart ensures absolutely no data gets lost in transit, and messages are never accidentally processed twice. So we've seen the mechanics of the flow on these diagrams, but a great architecture is really only as good as its practical application. So I have to ask you, when should you actually use this decoupled architecture in the real world? That brings us to our final section, section 5, when to use it.
Grounding theory in reality. Now, what's really interesting about this slide is how these high-stakes business scenarios map perfectly to specific service bus features. For financial transactions, looking at the first row, you're dealing with money. You need strict ordering and exactly once processing. You absolutely do not want a withdrawal happening before a deposit or a charge happening twice, right? For this, you would leverage the strict one-to-one processing of queues to ensure total consistency. Now, for video processing or e-commerce checkouts in the second row, your architectural needs shift a bit. Think about it. When a user uploads a video, you might need to generate a thumbnail, extract the audio, and run a virus scan, all at the exact same time. For this scenario, you use topics. You publish the video uploaded message just once, and 3 different subscriber services independently triggered their specific tasks in parallel. It is elegant, it's fast, and it allows your application to scale massively without hitting any bottlenecks. The ultimate takeaway here is really all about peace of mind. When you master this decoupled architecture, you prevent catastrophic data loss. You're actively insulating your different software components from each other's failures. If your invoice generator goes down for an hour, your website doesn't crash along with it. The service bus just patiently holds on to those requests until the generator comes back online. This asynchronous buffer is exactly how you scale applications to handle massive enterprise-level traffic with absolute confidence, ensuring every single message reaches its destination safely. So, I'll leave you with this final provocative thought to ponder as we wrap up today's explainer. Look closely at your own tech stack. What part of your current app infrastructure is just way too tightly coupled? Where are your services talking directly to each other in a way that feels a bit fragile? And how could sliding a message broker right into the middle of that flow untangle the chaos today? It's something to think about. Thanks so much for learning with us, and we'll see you in the next explainer.